Hello and welcome to another episode of Teaching Math. In the previous episode, I taught you how to correctly use a quadratic formula. Today, we are going to draw a quadratic function. So take your pencil in your hand and let's get ready to draw. Before we start, let me explain what a function is. Being in the title, you may think they are kind of a big deal. But function is just another word for formula, at least for now. I could bore you with the difference between them, but in this chapter, every formula is a function and vice versa. With that out of the way, let's discuss graphs. As I told you in chapter 3, when you need to draw a graph from a formula, you'll first need a table. Let's refresh our memory by making a graph for y is equal to 3x minus 1. We make a table with x and y. As x is the variable in the formula, that one should be on top and the y should be at the bottom row. Now we write down the numbers we want to fill in for x. As this is a linear formula, the table doesn't have to be that big. So I pick the numbers 0 to 3. But if you want to choose different numbers, that's up to you. Then I evaluate the formula for x with these numbers. So 3 times 0 minus 1. Then I calculate 3 times 1 minus 1. Then 3 times 2 minus 1. And lastly 3 times 3 minus 1. When I filled in the table, I can make a coordinate plane that suits my needs. I didn't pick any negative values for x, so I don't need to go to the left of the origin. And the lowest value for y is equal to minus 1. So this coordinate plane will do just fine. Then I plot the points from the table in the coordinate plane. And then I finish the exercise by drawing a line through these points. And that's how we make a graph from a formula. The same must be done if we're going to make a graph from a quadratic formula. In this exercise, we are going to draw the graph of y is equal to x squared minus 4. To make a graph, first we need to make a table. In the case of a quadratic formula, we need to make the table bigger. One that starts at x is minus 3 and goes all the way to x is 3. Again, you could choose different numbers, but let's not go there today. So this is my table. Then we need to calculate the values for y with the x's above. Because we do everything from left to right, I think it would be fun to start on the right side today. So first I will be evaluating y for x is 3. I replace the x for 3 and receive the line y is equal to 3 squared minus 4. This will give me 5 as 3 squared is equal to 9 and 9 minus 4 is equal to 5. Then we evaluate for x is 2 and we get 0. When we choose for x is 1, we receive minus 3 as our answer. And when x is equal to 0, y becomes minus 4. Then comes the tricky part, negative values for x, which means brackets. So for x is minus 1, we calculate y is equal to the square of minus 1 minus 4. The square of minus 1 is equal to 1. And 1 minus 4 is equal to minus 3. Then we fill in a minus 2 and calculate it appropriately. We receive 0 as our answer. You'll probably notice something here. Minus 1 and 1 gave me the same answer, and so did minus 2 and 2. That would mean by evaluating the formula for x is minus 3, my answer would become 5. And that's exactly what happens. We now have the line y is equal to the square of minus 3 minus 4, which becomes 9 minus 4, which is equal to 5. When working with a quadratic formula, at some point there is a tipping point, if you will. Most of the time, that point is in the middle of the table. That's why I told you to make it from minus 3 to 3. But never expect it to be always in the middle. Make sure you calculate it and are really sure you passed the tipping point before filling in the rest of the numbers. Now that we made the table, we can focus on making the coordinate plane and the graph. The horizontal axis goes from minus 3 to 3, and the vertical axis should reach a height of 5 and a depth of minus 4. After labeling everything and writing the correct numbers at the axis, we can plot the points. We place a point at minus 3.5, at minus 2.0, minus 1.3, 0 point minus 4, 1 point minus 3, 2.0 and 3.5. Now the graph itself. The line has to go through all the points in a smooth curve, so do not use your protector triangle for this one. When you're finished, it should look something like this. This graph is called a parabola and is the result of the square in the formula. Shall we make another? How about two graphs in one coordinate plane? Let's draw the graphs of y is equal to 5 minus x squared and y is equal to x minus 1. The quadratic table, that one will go from minus 3 to 3. But as the second formula does not contain a square, we don't have to make a table from minus 3 to 3. But if you want, you can make it as big as you like. I'm going to choose the numbers minus 3, 0 and 2, because I'm the teacher and I can do whatever I want. We'll start by filling in the quadratic table. 5 minus 3 squared is equal to minus 4. 5 minus 2 squared is 1. 5 minus 1 squared is 4. 5 minus 0 squared is equal to 5. 5 minus the square of minus 1 is 4. 5 minus the square of minus 2 is equal to 1. And 5 minus the square of minus 3 is equal to minus 4. Then table 2, the linear formula. Minus 3 minus 1 is equal to minus 4. 0 minus 1 is equal to minus 1. And in 2 minus 1, y becomes 1. Now that I have two complete tables, I can determine how big the coordinate plane should be. The horizontal axis will need to go from minus 3 to 3. The vertical axis has to go from minus 4 to 5. First we plot the 7 points from the quadratic table. Minus 3 point minus 4, minus 2.1, all the way to 3 point minus 4. Then we can draw the parabola through these points. Then we plot the points from our linear table. Minus 3 point minus 4, 0 point minus 1 and 2.1. This graph will become a straight line. To finish it off, we write the formulas next to each graph. And that's how you draw two graphs in one coordinate plane. Before we finish this video, let me explain one other part of this paragraph. When dealing with formulas, there are two different kinds of exercises. The drawing exercises that we discussed earlier, and exercises where you will have to answer several questions. These exercises are mostly accompanied by a picture or a sketch. To show you what I mean, let's take a look at this exercise. This here is a tunnel for bicycles. The arch of the tunnel follows the formula y is equal to minus 0.75 x squared plus 3. In this formula, y stands for the height of the tunnel and x stands for the distance away from the middle of the road. To figure out how high the tunnel is, we can use the formula. We just have to make sure we evaluate the formula for the correct value of x. As the highest point of the tunnel is precisely in the middle, that means x has to be equal to 0. So we evaluate for x is 0 and calculate y. Our answer here is 3, which means that this point over here is 3 meters high. You might also encounter a question like this. Max is 1.60 meters high. Can he stand underneath the tunnel at 1.5 meters away from the middle? To solve this question, look at the numbers the exercise has given you. 1.5 meters away from the middle is on the x-axis, which means we can fill in that number into our formula. If we do that, we have the line y is equal to minus 0.75 times 1.5 squared plus 3. Using a calculator will give you 1.3125 as our answer. This means that at 1.5 meters away from the middle, the tunnel is only 1.3 meters high. And that means that Max is unable to stand so far from the middle without bumping his head. So you see, nothing too difficult, but you do need to know how to use a formula and what everything means. Being able to use formulas in such a way is a very important skill, one that will help you in the future, so be sure to practice those exercises. In the next video, we'll start a brand new adventure in the land of algebra. We'll take our first step on the road in becoming masters of simplifying. You might think that simplifying means that we'll be working a lot with fractions, but don't worry, they only show up just to make sure you won't forget them. I hope to see you in the next episode. Bye bye!